So in this video we want to look at rationalising denominators. Now that's when a surd is on the bottom of a fraction. So I'm going to start off with one which is root 12 divided by root 6. Now one of the things we can do is just like multiplication, this could have 12 divided by 6 all square rooted, which is the square root of 2. There's nothing wrong with that. It's a very easy way to do that. However, I'm just going to show you a bit of thinking behind some of that. So root 12 can be rewritten as 4 times 3, and root 6 cannot be simplified at all, so I'm just going to leave that as root 6. But what I can do with that is make that 2 root 3's divided by root 6. Now this looks a bit different from the one that I've got at the top here, the root 2. Why is that different? Because I've still got that root 6 on the bottom. So to rationalise something like that, what I'm going to do is I'm going to do my fraction and I'm going to multiply it by root 6 divided by root 6. Now what I've got here inside this is the number 1. So it's not going to change anything or the way it looks. So if I now go through this, we're going to get 2, and root 3 times root 6 is root 18, and 6 times 6, or root 6 times root 6 is 6. Root 18 can be written as 2 times 3 times root 2, and of course I've got this 6 on the bottom, and these will cancel out to just give me the root 2 that I started with. So that's one way a method actually to rationalise is to times it by this number here. Okay, this number here, which is 1. So let's try this with a bit of a harder one. Let's try 2 root 3. So all I need to do is to say let's times it by root 3 over root 3, and that gives me 2 root 3's on the top, and root 3 times root 3 is 3 on the bottom. I'm finished. I'm actually done. Because I've rationalised, I no longer have a radical or a surd on the bottom. So that was really straightforward. Now, we'll just take it up a notch, but it's the same idea. The square root of 2 plus 1, all divided by the square root of 5. Now I'm just going to times this by the number 1. I'm going to write number 1 as root 5, root 5. So we might want to be thinking about this in a bracket. So we can do 2 times root 5, which is root 10, and 1 times root 5, which is root 5, and 5 times 5, or root 5 times root 5, is 5. Now I can't do anything with that because I'm not allowed to add the root 10 and the root 5. There's nothing that goes into root 10, no square numbers. There's no square numbers that go into root 5. I can't cancel the 5 with the 5, so I'm just going to leave it exactly like that.